Welcome to Shrinking AI's Memory, Breakthroughs in Machine Learning Efficiency, presented by AI Frontiers. Today's episode explores cutting-edge research from 89 recent cs.LG papers with a focus on model efficiency, adaptation, and interpretability. Special attention is given to the Kitty paper by Shah and colleagues, which highlights a key innovation in AI memory usage. Stay tuned as we guide you through the newest breakthroughs shaping the future of machine learning. Is AI's memory holding back its genius? In today's large language models, most memory resources are consumed by recalling context rather than planning ahead, much like a genius who cannot stop replaying old conversations. However, recent advancements have dramatically reduced this memory burden. Imagine an advanced AI assistant running on your phone that remembers your preferences and discusses new science, all without draining your battery. The question is, how did researchers manage to crack this challenging memory code? Let's set the stage for today's research journey. Machine learning powers a range of applications, from digital assistants to recommendation engines and medical diagnostic tools. The cs.LG category serves as the engine room of machine learning innovation, where new approaches are reimagined and refined every week. With 89 new papers charting the future of smarter and safer AI, this episode spotlights key breakthroughs, thematic trends, and a game-changing paper. By the end, you'll have a front-row perspective on the ideas shaping tomorrow's artificial intelligence. Machine learning can be thought of as the engine room of the AI revolution, while cs.LG research acts as the ship's logbook, chronicling every meaningful upgrade and innovation. This field covers a wide spectrum, including computer vision, natural language processing, model efficiency, fairness, and more. The learning process is often compared to teaching a child to ride a bike, beginning with supervised learning and progressing to unsupervised and reinforcement learning. Unlike humans, these models learn at lightning speed, sometimes detecting patterns invisible to experts. With dozens of new papers released each week, rapid innovation in cs.LG continues to shape the evolving AI landscape. Theme 1 centers on model efficiency and compression, as exemplified by Shah et al. Large models have become analogous to overstuffed suitcases, powerful but cumbersome. The need to travel light has driven the development of new quantization methods that shrink memory requirements by up to 8 times. This is akin to rolling clothes to optimize space in a backpack. The dynamic 2-bit cache quantization introduced by Shah and colleagues has proven both efficient and precise, opening doors for powerful AI capabilities on everyday devices. Theme 2 focuses on robustness and adaptation, drawing an analogy between AI models and chefs learning new cuisines. Models must effectively adapt to novel environments. The Bayesian online label shift estimation framework, developed by Wang et al., significantly outperforms previous methods, achieving up to 40% improvement in KL divergence, a measure of how closely predictions match true data distributions. This advancement ensures that model predictions remain reliable even as input data shifts, which is vital for real-world systems that must adapt to changing conditions. Theme 3 highlights interpretability and ethical considerations. Modern AI models must be able to explain their reasoning, moving beyond opaque black box decision-making. Research by Zhang et al. Employs spatial embeddings that align model insights with specific brain regions, enhancing transparency in brain-computer interface applications. Meanwhile, Li et al. Formalized the alignment trilemma, revealing unavoidable trade-offs between fairness, robustness, and efficiency. This is like turning on the lights in a dark room, illuminating how decisions are made and building trust in AI systems, particularly in sensitive domains. Now let's examine key findings from the most recent research. Shah et al. Achieved eightfold memory savings for large language models while maintaining performance. likened to a marathon runner carrying only a water bottle. Wang et al. Demonstrated 40% better adaptability to shifting data, reinforcing the dynamic chef analogy. Li et al. Mathematically proved the alignment trilemma, showing that reinforcement learning from human feedback cannot simultaneously achieve perfect representation, robustness, and efficiency. Chen et al. Compressed hyperspectral satellite data by a factor of 500, comparable to fitting a library into a backpack. Finally, Zhang et al. Set new benchmarks for brain-computer interfaces, combining high accuracy with interpretability. Let's dive deeper into the Kitty paper by Xia et al., which addresses the persistent bottleneck of key-value cache memory consumption in large language models. The key-value cache functions as the model's short-term memory, essential for maintaining conversation context, but prone to excessive growth as tasks become longer or more complex. Previous 4-bit quantization helped control memory usage without sacrificing accuracy, but reducing to 2 bits often impaired long context reasoning. Kitty introduces a dynamic ranking of memory channels by importance, storing critical channels at 4 bits and the remainder at 2 bits. This approach achieves nearly an 8-fold reduction in memory use while retaining near full accuracy. Continuing with Kitty, the implementation features a clever engineering solution, splitting the cache into 2 unified tensors, each at 2-bit precision. This structure enables efficient dequantization using Triton kernels, ensuring fast access without any disruption to the memory layout. As a result, practitioners can process up to 8 times larger batches or realize 2 to 4 times higher throughput, even on modest hardware. This breakthrough makes advanced AI capabilities more accessible across a broader spectrum of devices. The Kitty framework also represents a pivotal step toward democratizing AI. Its open source code invites global collaboration and real-world application. The approach was inspired by practical needs rather than purely theoretical considerations, bridging the gap between cutting-edge research and everyday use. By empowering more users and accelerating further innovation, Kitty stands as a toolkit that moves the field closer to truly accessible and inclusive artificial intelligence. Looking ahead, today's breakthroughs lay the foundations for the future development of AI, likened to building the infrastructure of a growing city. The ongoing quest for fairness, transparency, and adaptability in machine learning is akin to city planners ensuring every neighborhood can thrive. Anticipate the emergence of more universal, multimodal models, increased open collaboration, and a greater emphasis on ethical responsibility. Your curiosity and engagement can help shape the next major leap in artificial intelligence. To conclude, let's recap the key themes explored. Efficiency through quantization as demonstrated by Xia et al., adaptation via advanced estimation techniques from Wang et al., and fairness illuminated by Li et al. Technical concepts such as self-supervised learning and the alignment trilemma were discussed, highlighting both the remarkable progress and the unavoidable trade-offs inherent in modern AI. Listeners are encouraged to examine the referenced papers, participate in ongoing discussions, and help push the boundaries of what AI can achieve. Collectively, the community shapes the future of artificial intelligence. This episode was synthesized using the GPT 4.1 model for natural language summarization, with TTS generated by OpenAI and visual concepts crafted through Google's image generation based on textual descriptions. Human experts reviewed all content for coherence and accuracy, though some oversights may remain. For complete details and further exploration, all referenced papers are available for your review. Please consult these sources for in-depth information. Subscribe to AI Frontiers to stay at the cutting edge of artificial intelligence research. Receive weekly insights from the latest papers on the arXiv preprint server. Join our community to ask questions, share your ideas, and remain engaged with emerging trends. AI Frontiers is your source for the next wave of machine learning innovation. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer, this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.